All right, in questions 3 and 4, we're looking at angles that are between 90 degrees and 180 degrees and the trigonometric ratios. So we know for the first quadrant, we know the sine value is positive. The cosine value here is also positive, in the positive x direction. We also know the cotangent value is positive, also in the x direction, and the tan value, tan ratio, is positive as well. But now let's have a look at what happens if we start our angle, measure past 90 degrees and go into the second quadrant, so like this. Alright, so here we have our point here, and the sine value we know is the y value here. So the sine, we can say, let's give this angle a name. So we can say sine theta is positive. If we look at the cosine theta, we see now it's going in the negative direction for x. So the cosine of theta is negative. If we continue this, that line for the angle here in both directions, then we can determine the cotangent. So that's measuring from horizontal at the top of the unit circle. So that distance, we can say for cotangent is a negative value. It's going in the negative x direction. Maybe we should just put these in brackets here. And for the tangent, measuring from this point of the tangent towards the angle line, this is in the negative direction for y, so we can say that the tangent is going to give us a negative value. So in all, the only trigonometric ratio that's positive in the second quadrant is sine. So that's going to help us with these questions here. Now, we know that the sine will be positive, so this is true. We know the sine is positive, but here it says negative, doesn't it? So that's false. For the tangent ratio, we know that this should be negative, so that's going to be false. The cosine we also know is negative, so false. Alright, so question 4, we're doing some calculations of actually evaluating some angles. So let's firstly simplify this. We'll take the tan value of 120 would be, looking at the supplementary angle, would be tan 60. I'll just put the angle in brackets. It's not important, just for clearer reading. And it's the negative value of this. Let's draw the denominator. The next value we have here is minus sine of 135. So it'll be minus the positive sine of the supplementary angle, which is 45. And plus the cosine value for 150. We saw that should be negative cos 30. Oh, can I fit this in? Yes, beautiful. And lastly, the cotangent, the supplementary angle is 45 degrees, and we know the cotangent ratio is negative in that second quadrant. Great, so now we just have to remember our exact value triangles. So for 45 degrees, we have 1 root 2. For the 60-30 triangle, we start with an equilateral triangle, side length 2. If we halve it, we have 30 degrees here, and root 3. So these are going to help us. Let's now simplify. Tan 60, well, here's our 60 degrees. Opposite over adjacent would be root 3, so minus root 3. For the sine value here of 45 degrees, let's look. 1 over root 2, so minus 1 over root 2. Cos 30 degrees, let's look at the 30 degrees here. Adjacent over hypotenuse, so minus, plus minus, notice. So minus root 3, root 3 over 2. And lastly, the cotangent of 45 degrees, well, let's take this one. Adjacent over opposite, is going to give us 1. Alright, so now it's just a matter of simplifying this. We know that dividing by minus 1 would just simply change the signs of all of these values. So if we could simplify this by just making all of these positive, root 3. Now, what we could do here for this this middle term is to rationalise the denominator by multiplying by root 2 over root 2. And so we get minus root 2 over 2. Root 2 times root 2 will cancel the square root. And this negative term here will become, sorry, I forgot to multiply by -1. And lastly here, we should multiply this last term by -1 also, or divide by -1, which is the same thing. And taking a common denominator of 2, multiplying all of this here gives us 2√3 and plus √2 plus √3. And you got it here, you got some like terms. √2 plus √3 gives us 3√3, and we have our answer. Well done, hope you enjoyed this video, and we'll see you in another one.